This video covers the review for section 4.2 in trigonometry, law of cosines. With the given information, angle C is 29 degrees. Side A is 20. Side B is 32. With this given information, the side angle side, we can't use law of sines anymore. So we have to use the other one, which is law of cosines. Given the angle C, we're going to find the side associated with that first. And so remember that formula is the side that you want, C squared, and then equals the sum of the squares of the other two sides, A squared plus B squared. It's like this Pythagorean theorem thing, but it's not a right triangle. So we have to subtract off this 2AB cosine of the angle that we're given, C. And so remember, we're finding C. So all we're going to do is take the square root of all that stuff that we put in there. A squared plus B squared minus 2 times A times B times the cosine of 29 degrees. So you put all that stuff in your calculator and you end up with 17.44954,942. So remember, that's side C, and we're rounding to do 2 decimal places, so we'll round that to 17.45 for now. Okay, so now we have all 3 of our sides. Now we have to find one of the angles. And so you want to be careful with this one. And because the easiest thing to do now is to use law of sines. We're going to use law of sines to find one of the unknown angles. However, if B turns out to be obtuse, law of sines will not find it. It gives you negative angles when they're really obtuse, because the law of sines, when you do inverse sines, the inverse had the outputs that was either in quadrant 1 or quadrant 4. So it's always the best bet then to use law of sines to find the smallest. There's got to be 2 acute angles, and if it's obtuse, so find the smallest angle. And so we see that's going to be angle A. So we say sine of angle A, which is what we want to find, over its associated side, which is 20, equals sine of 29 degrees, because that's what we were given, over, don't use 17.45, use 17.4495, 4942. So solving for A, we would take 20 times the sine of 29 degrees divided by 17.44954942, and then we'd have to take the inverse sine of that to find A. So this gives us 33.75688018. So like we expected, that had to be acute because we were finding the smaller of the angles that we needed to find, A versus B, and we'll call that 33.76 degrees. Now, B is easy to find because all the angles add up to 180. 180 minus 29 minus this 33.75688018. And this gives us 117.243119. And then we round that to 2 decimal spaces, 117.24 degrees. So yes, obviously my picture is drawn incorrectly now that I know that it's obtuse. However, I like to draw these just as reference, not necessarily to scale. Okay, so that's the case where you have the side angle side. The angle you're given, you're not given the side associated with it, so you can't use law of sines. So remember, in this case, you first find the side associated with the angle, and then you go after the smallest angle. Whereas the other type of law of cosines is when you're given all three sides. Again, drawn just for reference, A, B, and C. Side A is 18, side B is 12, and side C is 9. Here's the biggest side. So if there's going to be an obtuse angle, it's going to be across from A. So then use law of cosines. When you take an inverse cosine, it outputs obtuse angles. So use law of cosines to find the largest angle. If it's obtuse, we'll get it out of the way right from the start to find the largest angle, and that largest angle is going to be A. Okay, so we know then that if it's the angle A that we're after, the cosine of A, then that means we're going to have to use its associated side, A squared. And so then that will equal the other two sides, the sum of their squares, minus 2 times BC times cosine A. So let's go ahead and manipulate this formula right here by adding 2BC cosine A and then subtracting A squared, and then divide by 2BC. And that's going to say cosine A equals B squared plus C squared minus A squared divided by 2BC. And then we'll just take the inverse cosine of that. All right, so we put all that stuff in there. 12 squared plus 9 squared minus 18 squared divided by 2 times 12 times 9. And when we work that out, angle A comes out to 117.2796127. We'll round that to 117.28. But as you see now, angle A being obtuse, if we had done this backward, we could have gotten fooled up and had a hard time finding the obtuse angle. So it's always the safest bet to find the obtuse angle first. And now there's only one obtuse angle in any given triangle. So now it doesn't matter which angle we go out and find. You're welcome to use law of cosines. However, law of sines is always a little easier to use. So again, to find B or C, it doesn't matter. I'm going to find B. So we take the sine of angle B divided by 12 equals the sine of A, we now know is 117.28. So we're going to take sine of 117.2796127 divided by its side 18. And then from this formula, we see that B is equal to the inverse sine of 12 over 18 times the sine of 117.2796127. 12/18 times that. So when we find that inverse sine, we get 36.3360571. We'll round that to 36.34 degrees. And now we have to find C. C is 180 minus 117.28 minus 36.34. When you're finding these angles, you don't need to use all the digits. This gives us 26.83. All right, so to recap, when you're given all three sides to a triangle, make sure you find the obtuse angle first if it exists. Go after the largest angle first. If you're given the side-side angle case, use law of cosines first to find the side opposite, but then use law of sines to find the smallest angle. That way, the obtuse angle will come about just by doing the 180 minus the two angles. And this concludes the video for section 4.2, review, law of cosines and trigonometry.